We think we live at a fixed address in the universe, Earth, the solar system, the Milky Way galaxy. But what if our galaxy itself is caught in a massive cosmic current, hurtling towards an unseen destination at over 2 million kilometers per hour? This isn't a science fiction scenario. This is the cosmic reality we live in. Today, we're going to talk about a mysterious, massive structure that is pulling our galaxy and tens of thousands of its neighbors, the Great Attractor. It all began in the late 20th century when astronomers mapping the universe noticed a strange anomaly. We know the universe is expanding. This means that, in general, galaxies should be moving away from each other. However, measurements revealed a startling fact. A vast group of about 400 galaxies, including our own Milky Way, was being pulled toward a specific region of space in the direction of the constellations Centaurus and Norma. This wasn't a simple motion, it was a local force, counteracting the overall expansion of the universe. In this region, roughly 150 to 250 million light-years away, there had to be an immense gravitational source, far beyond what was visible. Astronomers gave this source a fittingly descriptive name, the Great Attractor. But there was one major problem. This mysterious region lies directly in the plane of our own Milky Way galaxy. We call this the zone of avoidance. The center of our galaxy is filled with billions of stars, dense gas, and clouds of dust. This cosmic curtain makes it nearly impossible for our optical telescopes to see what lies beyond. For decades, the Great Attractor remained a secret, hidden behind our own galaxy. So how do scientists study something hidden behind the Milky Way? The answer lies in going beyond visible light. Where optical telescopes are blind, infrared and X-ray telescopes come into play. These wavelengths can penetrate the galactic dust, allowing us to see what's behind it. Scans made with these new tools revealed the presence of dense galaxy clusters in the zone of avoidance. The most prominent of these, is the Norma cluster, thought to be near the heart of the Great Attractor. But there was a discrepancy. The total mass of all these observed galaxy clusters wasn't enough to explain the immense gravitational pull affecting us and our galactic neighbors. There was a missing piece in the equation, and that piece was dark matter. The observed gravitational force required far more mass than was visible in that region. The Great Attractor became one of the most powerful pieces of evidence for this invisible substance that shapes the large-scale structure of the universe. But the story doesn't end there. In 2014, a groundbreaking study showed that the Great Attractor is not an isolated anomaly, but part of a much larger structure. By analyzing the movements of tens of thousands of galaxies, astronomers mapped the cosmic flows of the universe and discovered a massive supercluster that our galaxy belongs to. They named this structure Laniakea, which means immense heaven in Hawaiian. Laniakea is a structure of mind-boggling scale, stretching some 500 million light-years across and containing over 100,000 galaxies. And the Great Attractor? It's the central, deepest gravitational basin in Laniakea. In other words, we aren't just moving toward an object. We are flowing toward the deepest valley in a vast cosmic river. And there's more. Laniakea itself is influenced by an even larger structure, the Shapley Supercluster, one of the densest concentrations of galaxies in our cosmic neighborhood. This shows that the universe is composed of nested, layered structures. We exist within a hierarchy, from a local gravitational basin to a larger one, and then to the influence of a colossal supercluster. The universe is not made of randomly scattered galaxies in a void, but a cosmic web of vast clusters and voids, all connected by gravitational filaments. The Great Attractor is one of the densest nodes in this web. So, what does all this mean for us? First, it directly affects how we measure the universe. The Milky Way's motion toward the Great Attractor at about 600 kilometers per second is called a peculiar velocity. When astronomers calculate the Hubble constant, the rate of the universe's expansion, they must subtract this local motion from their equations. If they didn't make this correction, all our calculations about the age and size of the universe would be skewed. Second, it solidifies the role of dark matter. The visible matter in the Great Attractor region cannot account for its gravitational pull. This proves that dark matter, which makes up about 85% of the matter in the universe, is the architect of large-scale structures. Third, it redefines our cosmic address. We used to think that the Virgo cluster, which we are a part of, was our supercluster. The discovery of Laniakea showed that the Virgo cluster is merely a small branch of a much larger structure. First of all, let's be clear. The Great Attractor is not a threat. It's not a black hole or a monster devouring galaxies. It is a gravitational region composed of galaxy clusters, gas, and predominantly dark matter, which gently guides the motion of the galaxies around it. This journey will not end in a dramatic collision. In fact, in the long run, gravity will not win this cosmic tug-of-war. The accelerating expansion of the universe, driven by dark energy, will overcome even the most powerful gravitational basins over billions of years. Other galaxies in Laniakea will eventually drift beyond our observational horizon, leaving us gravitationally bound only to our closest neighbors in the local group. For now, however, studying the Great Attractor and Laniakea offers a unique opportunity to understand our place in the universe and the forces that shape us. Radio telescopes like Milky Way and the Future Square Kilometer Array will map the zone of avoidance in unprecedented detail. Next-generation X-ray missions will provide new insights into the distribution of mass within these superclusters and the nature of dark matter. In conclusion, the Great Attractor is far more than just an anomaly. It's a window that allows us to see the hidden skeleton of the universe, the cosmic web. As part of the Laniakea Supercluster, it reveals the invisible forces that have shaped our galaxy's journey over billions of years. Every new discovery refines our position on this vast cosmic map, reminding us once again just how complex, interconnected, and magnificent the universe truly is.